Hello, welcome back. This is Calculus by Dr. Oz. Today we're going to choose a method to find the volume of a solid and what are the available methods that we have. Either disk or shell, this disk or shell method, and this could be like also another version of that is a washer method. So we're going to choose in between washer and shell method. To write and evaluate the definite integral representing the volume of the solid generated by revolving the plane region, which is made of two curves, about the line x equals 3. First off, x equals 3 is a vertical line, and the region is made of two curves. And first I want to show you like what this region looks like, and you'll find the details in the video. So my region is bounded below by the blue curve, which is the cubic, and above by the purple curve, which is a quadratic. And now I'm going to revolve that region about the x-axis. So here you have to decide to choose in between washer or the shell method. So here the rule of thumb is that how are the functions defined in the question statement. So as you see that we have two functions provided to us and each are written in terms of x, and that means it's not always the case though, but that means it's more appropriate to write down the volume integral depending on x. So if you want to have an integral written in terms of x, you should be able to get a vertical slice with thickness dx, so that when you revolve it around for this type of problem, you're going to get a shell. I think the shell method is more convenient, but anyway, you will find the details within the video to see which region I'm going to pick. But before we get started, let me just show you what the three-dimensional object looks like. So this is our region between these two curves, and we keep revolving this around. Okay. So you get like nice half of an egg, and then you just subtract the volume of horn type shape, three-dimensional shape, off the volume of the half egg looking like structure or object. So we get this volume. So please watch the rest of the video to see what technique I'm going to pick to write down the volume integral. All right, let's get started. All right, let's handle this problem. We have the region bounded by y equals 1/3 x cubed and y equals 6x minus x squared. And we're going to revolve the region about the line x equals 3. Well, first off, why don't we go ahead and find intersection points here, okay? So I'm going to solve this equation by setting 1/3 x cubed equal to 6x minus x squared, okay? So let's multiply both sides by 3. So x cubed equals 18x minus 3x squared. And simplifying this gives you this equation, okay? And this is a cubic, but well, you can factor x out. So this should be x squared plus 3x minus 18 equals 0, okay? So I need to find the roots here, or zeros. 1, 0 is obviously x equals 0. Okay, I'll just write that down here right away. And the other 0 is found by solving the quadratic, okay? And this is sort of like a good workout for you. I can just tell you that I can factor this quadratic as, let me just write it here, x plus 6, x minus 3, okay? And please check that. In fact, you can use the quadratic formula if you want to. And you have two more roots coming in, x equals -6 and x equals 3. Okay. So which ones are more relevant? Our region is bounded by x equals 3. So I don't think that we're going to go all the way to -6, but for your own reference, why don't you plot the cubic together with the quadratic here, okay? And see what the region looks like, and maybe we won't need x equals -6. I can tell you, in fact, we won't. Okay, we have x equals 0 and x equals 3. And please plot in your graphing calculator. You can pause the video anytime. I'll show you what I got here. Okay. As I said, the intersection points needed for this problem are 0 and here x equals 3, vertical line. Okay. And the region, the bounded region is the green region. At the top you have the purple curve, which is the quadratic. And the blue curve here is the cubic. Okay? And we are going to revolve this region about x equals 3 vertical line. This is x equals 3 vertical line. Okay? So just to see like what kind of three-dimensional object we're talking about after the revolution. So here is the region that we have, okay, bounded by two curves. Okay, so we're talking about this green region here. Okay, we just keep revolving that. And as you see, I get this nice three-dimensional picture. Okay, and I'm going to try to find the volume of that. So this part is taken out, right? So it's the volume of this whole piece here. Okay, but I take this part out. So this is out. Okay, so the region, the three-dimensional volume we were talking about is just this red part only. Okay, so we just take that part out. All right, so black part out, a little like horn-shaped stuff, right? So the question is, what technique am I going to use to write down the volume? You can use the disk or shell method, but which one is more convenient for this problem, and how am I going to decide about it? Okay. Well, first observation in deciding which technique you're going to use is the form of the functions provided to you. And in this case, you are given the y equals f of x or g of x representations of the graphs. So eventually I'm going to solve an integral. I don't want to deal with integrands, hard to integrate, involving square roots or cubic roots or something. So it's better to keep the integral depending on x. But let's check. So if you want to keep the integral depending on x, and if the axis of revolution is the vertical line x equals 3, it's better to get like thickness to be just like dx, so that I can write, like in this case, I have this slice here, vertical slice. When you revolve it around, you're expecting to get a shell like this. All I need is to write down the radius p of y and the height of that h of y, sorry, not p of y, I'm sorry, p of x, and h of x, because everything is depending on x in the shell method, right? In terms of these functions here, okay? Right here, all right? So, but the question is like, is this a better way to go with? What if you use the disk method? So that means I'm going to, in fact, in this case, it's a washer method, right? Because there's some distance between the slice and the axis of the revolution. So after the revolution, so it's going to be like a washer. Okay. Okay. So, well, now the thickness is dy. Okay. And I got to write the inner and outer radii. So let's say this is the outer radius, and this is the inner radius. So you have to write all of them in terms of y, okay? But we're given the x representations of these functions. I have to solve each equation for x and write everything in terms of y. What I mean by that here is that x cubed, for example, in the first case is 3y, so x is cubic root of 3y. And here solving for x is not that easy because you have to use the quadratic formula, and that's going to be ugly. So for this one, x equals something, that's going to be very ugly. So I don't want to work with very ugly expressions, because at the end of the day, I am going to tackle with the integration. So for this problem, I think the shell method is very convenient because I can write h, p, and h and p in terms of x, right? dx, h of x, and p of x, that's the radius. So for that reason, I'm going to continue using the shell method for this problem. All right, so for the shell method, we just say like this slice is x units far from the y-axis. Let's say like this slice is x units far from the y-axis or the origin. Okay, so the corresponding height of the slice is determined by blue and purple curves because the bottom portion of the slice touches the blue curve and the upper portion, upper end of the slice touches the purple. Okay, so all I need to know are the y coordinates of these points. Okay, y coordinates of these points because I'm going to look at the difference in between. Okay. All right, so since we have, let me just clean this part to make some space here. So this part here, this distance is the distance between the x-axis and the blue curve, okay? Corresponding to that very first dot, which is the bottom part of the slice. And that's ruled by the blue curve, so that distance is going to be 1/3 x cubed, okay? And this distance here, okay, let me just use this kind of way of showing it. This distance here, let me just write here, is determined by the purple curve, which is 6x minus x squared. Okay, there we go, 6x minus x squared. And all I need is h.